to Disco Lady Ada.
Hey everybody, and welcome to another Disco Lady Ada. It's me, Lady Ada, and this is my desk. And tonight we're going to do number 6 of a series of 10 Raspberry Pi Zero project tutorial videograms, where I'm going to show you something you can do with a Raspberry Pi Zero that you could use to maybe win some stuff. Free stuff. That's the best kind of stuff to win.
Yeah, first up, this is part of the Hackaday Prize.
Tell me about it.
That we're doing the contest, and you are showing people ideas, suggestions, tutorials, and more so they can win a Raspberry Pi Zero. There's none available. Someone made a single serving site, which is kind of cool. It just shows that they're...
Find me at raspberrypi0.com or something?
Yeah, they're not available anywhere. And instead of just, complaining about it, we thought
we'd give them away.
We thought we'd find 10. We have 10. And we'd give them away. And all you have to do is...
This is my secret stash, too. These are like my zeros.
Yours. See, that's how you can tell. And so far, there's 65 entries on hackaday.io. That's all you have to do is put up your idea. And some of the rules, February 2nd to February 20th, we're going to make these 10 videos. Folks on Hackaday are going to pick the winners. It's just for ideas. And
on the 25th, you have up to February 25th to enter your idea, and then the top 10 most well thought out and well documented ideas will win one of 10 Raspberry Pi Zeros, and then you'll get them in a couple days after that, and then the grand prize is chosen on March 14th. So after you get your Pi Zero, you still have a couple weeks to prototype your project, document it, get it all ready to go, and enter to win one of $300 gift certificates from the Hackaday store. They don't have Pi Zeros there, but you can get all sorts of stuff you can plug into your Pi Zero, like real-time clocks and radios and Wi-Fi dongles and all that good stuff.
So anyways, we thought this would be a good way to get some Pi Zeros out there into the hands of folks just for coming up with ideas.
Yes.
So, Lady Ada, what do you want to show tonight?
So tonight we're going to be talking about audio because we did video for the last couple nights, and I'll take a break from that. We showed people how to get HDMI out, play videos, like have Minecraft, have emulators, have small TFT displays, have NTSC output, have SPI output, and now that we've done the video, let's go back and we'll do the audio half. So audio is not super easy to do on the Pi Zero because it doesn't have the headphone jack that most Raspberry Pis have. Here I've got a Raspberry Pi. I'll demonstrate what it doesn't have. Usually the Raspberry Pi has a little audio jack right here, and you would plug into that and get your stereo audio out from there. But you don't have that on a Pi Zero. It was left out. It was left out partially because the headphone jack takes a little bit of space. Also, the connector is expensive, and also they figured there's a lot of other ways you can get audio out. And if you want to do audio right, you want to do some filtering anyways or do digitally. So, that said, we can show you how to add audio. We're going to show you a couple different ways. So you have, I think, 3 different options we're going to show. We're going to show using the PWM output and just a little bit of filtering to get analog output. Using a USB sound card, which is pretty easy as well. It's probably the easiest of it's tied for the easiest of the 3. And then the third option is adding a DAC, an I2S DAC, using a fat DAC shield or hat, or you can DIY your own with a chip that does I2S digitally without I2S input without needing an M clock signal. So I guess we'll go right for it. You want to go to the computer and I can...
Yeah.
All right. Here we are in computer land. Whoa. Sorry, I was going to show the... this is a contest page. So there's me. I'm giving out Pi Zeros. And here you can see all the previous videos if you'd like. They're all documented. We have 5 videos up. And, of course, we'll be doing another 4 after this. And if you guys have questions... you can send them to Adam and Sophie. You can post them in the discussion. They'll answer technical, contest-related questions. If you have technical Raspberry Pi questions, you can ask them in the chat here, whichever chat you're on, YouTube or Twitch or whatever. Or, send them to Sophie and Adam. They can forward them to me. Or ask them right now while we're doing these live videos. They are live. It's me. I'm made out of meat. So the first version I'm going to show for audio is this one. And this is basic audio output. So the nice thing about doing this is it's like really inexpensive. You can basically do this for like 20 cents in parts. And probably you have these parts already kicking around. So this is the PiZero, and there's HDMI, and there's USB data, and there's power, and there's SD, and there's the GPIO, which we talked about yesterday. Or was it yesterday or Sunday? Sunday, I think. Well, on Sunday, we talked about the GPIO. But there's no audio out. There's a TV out. They actually gave you the little TV NTSC output pin, which is kind of nice, but there's no left-right audio. So instead, what we're going to do is we're going to replicate basically the Raspberry Pi audio filter from the Pi 1 and Pi 2. And in this case, what those Raspberry Pis did is there's no analog output on the BCM2835. It's meant to be a video coprocessor for a phone. The phone has its own. Usually, actually, by the way, it does digital audio anyways. It doesn't have analog audio out. It does digital audio. And so we can fake it by taking the two PWM lines, PWM0. Let's make this bigger. PWM0 and PWM1. And we filter them. We have a little RC filter here to low-pass filter, get rid of the high-frequency PWM. We'll look at that on scope cam later. And then we also divide down a little bit to give us line level. And then we have a DC coupling capacitor, or it's AC coupling capacitor. I guess it DC blocking AC coupling capacitor to get your audio out, right, audio out, left. I don't even know what to say, L. This is audio left and audio right. And then you just connect ground to ground, and you're good to go. So the side effect of this is, okay, it's really inexpensive. As you can see, you only need like a couple of resistors and a couple of capacitors. These are ESD protection diodes. You know what? If you're messing around with your PiZero, you already stuck your filthy hands all over it anyways. You can probably skip this. Although if you have diodes kicking around, sure, you can add them in. The side effect is the audio is not the best quality because the PWM input is first off, it's noisy because it's PWM, but it picks up all the noise from the circuitry around it. So it's not going to be the most like audiophilic of outputs, but it does work. So let's show how to do that. Pretty straightforward. So on the PiZero, what you normally get on the Raspberry Pi 1 or 2 or B or whatever is they use pins 40 and 45. And those are multiplexed with PWM0 and PWM1. And then, you can use those for PWM. And then you have the rest of the GPIO pins. Now, those pins are not brought out on the PiZero. You only get the standard GPIO headers. They don't break out. Or maybe they are broken up, but they're on test pads, and I don't know which pins those are. However, what you can do is, if you look at, remember yesterday or 2 days ago, we talked about all the GPIOs. Well, GPIOs have functions. And like I said, some of them have special functions like I2C or SPI, and some of them also have that PWM function. Remember, we had pin 18, and we could dim and brighten an LED connected to it because that's PWM output. So GPIO 18 has, PWM0 as a function, and PWM1 is also available on GPIO 19. It's also available on, I think was it GPIO 5? Hold on. PWM1 is available on GPIO 13, 19, 41, 45, and PWM0 is available on 12, 18, and 40. I do not know why these are crossed out. Bold is default function. Okay, so I don't know what crossed out means though. GPIOs are connected on the Raspberry B Model 2 circuit board are crossed out. Oh, these are the original 26 pin. That's why they're crossed out. But they're available on some of these are available now on the PiZero because it's a full 40 pin connector. So now that you know that you have these alternate functions, all you have to do is set them up to be alternate functions. To do that, you can use the wiring Pi tool that we used before. You remember yesterday we used that to control the PWMs. So GPIO read all, and you can use that and it will tell you what pins have what functions. So for example, you can see RX and TX have Alt 0. And these are the BCM pins. Actually, kind of was messing this before, so let's see. GPIO 5 is an input. These are actually all inputs. Yeah, so basically the only pins that have special functions are, I set pin 18, so this is BCM 18, I set to Alt 5. The rest are inputs, just because I was already messing with it to make sure this worked. Once you have looked at all the list of your GPIOs, you want to change the functions. Well, that's pretty easy. You can do that by basically poking at some registers, and there's a very handy tool that was written by Tim G. Thanks, Tim G. And this just does the memory mapping and like tweaks the register to set the function for you. So you would copy all this code into gpio.alt, which I've already done. You paste it in. It's a very simple C program that just, it's actually kind of messed up, by the way. Like when I first saw this, when you do this with a microprocessor, I was like, this is against the law, but it's actually not. You can open devmem and just like read and write from it, which is like super messed up. Like, I mean, I know, like everyone does it, and it's how you handle register accesses, but there's something about it that weirds me out, that you're just like, hey, I'm just gonna like memory map all of memory and then just like read and write from it. Just like that. Like I'm not gonna use like registers or anything like the normal register commands. I'm just poking memory. Weird, but I guess that's okay. Anyways, so yeah, you can memory map. So you compile this. And you install it. And then now you can set alternate functions. So you can set pin 13 to alternate function 0. You can set pin 18 to function 5. You can set pin 18 to function 0. And then when you do that GPIO read all, 18 will say alt for whatever it is. So it's 0, and I can set it to 5. Do read all again, now it's alt 5. And 18, if you set it to alt 5, is PWM. And if you set 13 to 0, it's PWM1. I mean, you have a choice of which pins you want to use for PWM 0 and 1. Like there's, again, 4 or 5 different options. These are just the ones that my tutorial uses. Go to town if you want those pins. Just note that you can't use the PWM. Like once you've muxed the PWM 0 and 1, you don't get to use those on other pins. Like it's not like there's multiple PWM 0s. There's only one, and you get to redirect which pin it goes to. You don't get to have multiple. So you only get 2 PWMs. So if you want to use them for audio, you can't use them for LEDs. You got to come up with something else. Okay, so once we do the alt stuff, we can go to scope cam.
All right, we have a new scope cam tonight.
What?
We have a new scope cam.
We have a new scope
cam.
cam.
Yeah, we do.
Show them the new. We can do quad cam too. That's also good. Okay, so this is scope cam, and I have this probing pin 18.
I'm like the James Cameron of live electronic videos. Here we are under the sea.
So what we've got here is, I'll keep channel 2 on, 50 megahertz, which is pretty sweet. A little high frequency there, but it works. And we'll look at this in quad view, but basically this is the PWM signal. I mean, it's ridiculous, but I guess that's what it is. Actually, I have bandwidth limiting too. And what's kind of interesting is, just because my scope, the way it aliases, you can it's kind of weird. It looks like it's a lower frequency, but it's not. It's actually a pretty high frequency. So, awesome. Oh, and that says, yes, it's totally confused. But yeah, it's pretty high frequency. But what you can do is, so let's go to the overhead, the hover cam.
Yeah. All right.
Okay, so
we're still doing this.
well, yeah, I will wire up that.
We use all parts of the desk of Lady Ada here.
Yeah. So let me wire this up. So I'm going to grab GPIO 18, and then I'll move it over here. And then I have to see what resistors I've got. I'm going to kind of fake this a little bit. It's not going to be the most correct values, but I think it's okay for now. So we have a divider here. Let me grab my jumpers. Give myself a reference ground. Okay. Well, the thing is, this is kind of wants to. That's fine. And then we need a capacitor to ground, and the value. I've got some 0.01 microfarad. Again, I'm not using the right values, but sometimes it's just life. So I don't want to spend like a half an hour digging through my resistor packets. Okay. So. Okay, so let's look at the signal now. Can we go to multicam? Let's try multicam. Okay, so this is what I've got wired. I did a little bit of this, and it's over here, and I am going to probe right here after the little filter. And you can see I've got, hold on, I don't have mean. Okay, so I've got a mean of about 800 millivolts. That's my DC. And then I can, in my console, can try playing some audio. So Raspberry config. I already did this, but you'll need to go do basically just set the headphone to be out. It will do the also mix stuff, and then you can do a play L, and it will show you that you have a card. ALSA card on device 0, and that's what we want to use. And then let me just get my exact command for this. Hold on. Okay. Speaker test -C2, 2 channels, wave play, and then play the front center test wave. So hopefully. That's odd. Hold on. Yeah, so what I do see is the signal is changing. Maybe my filter wasn't very good. Maybe I have to update my volume. Hold on. is it a mixer? Is it also a mixer? Turn this all the way up. Oh, there you go. Yeah, my volume was just too low. Okay, so now that my volume is reasonable, you can see on the output I'm getting a nice audio effect every time it plays the audio test. So now that that's working, we can, actually I want to add this divider back in. Well, that really kind of kills it. But, you know, I actually do want it to be low. Okay, hold on. And then I need that filter capacitor. 1 second. Bag o' caps. Okay, oh, I even have a handy 10 microfarad. Hook up the 10 microfarad to the output. And then I have a headphone jack, connect ground to ground, and then I'll just connect one channel for now. And then for output, this can't drive anything but the crappiest headphones, so you definitely want to use powered speakers. These are some powered speakers. They're USB powered, and they're powered through the hub. So you can just, hold on, use the audio connector.
Center. Front. Center. Front. Center.
Sorry, it's this one.
Front. Center.
So,
Ter. Front. Center.
so it's not bad. That's okay.
Front. Center.
And that's only one channel. You know, you can wire up the second channel if you want, if I was not feeling lazy. But you can connect up both channels and then you get
Front. Center.
left and right.
Front. Center.
Yum.
Front.
So that's audio. And it's basic audio. I mean, it works. And once you have audio working, of course, you can do more stuff than just play kind of a disembodied woman's voice saying front center. You can play MP3s, you can play OGG Vorbis files, you can play WAV files, you can have video games that have audio output, you can play music. For example, can you go to the just computer screen? Bleep.
So just straight up compare.
Yeah, just because I have to look up some stuff. So you can go to Soma FM, for example. This is kind of, I like to do this test. It's kind of fun. It's like, this is stuff that's easy to do. There's a DEF CON radio. You go to the direct stream link. You get the direct server link, and then you can play, well, except you should delete the part that says direct server. And you can play music. Only for a few seconds, though, because YouTube gets pissed if you do more than that. So you can have some ideas. You can do a Wi-Fi radio. You can do an alarm clock that plays music. You can have something that is a synthesizer, or a music-making device, a MIDI interface or something. Some other ideas. You're creative.
Other ideas for
Audio playing PiZero projects.
I think one of the ideas that you can do for an audio playing PiZero project would be to look at some of the early Arduino projects that used a wave shield or some type of MP3.
Yeah, didn't one woman, she had like a crow, and the crow, like
Yeah.
it was an animatronic crow, and it cawed.
Yeah, I mean it'll
kinda
be
cool.
It's easier to do things that are internet connected and more with a PiZero. So I would say if you wanted to add those things like a crow that tells the weather, you can have a lot of decisions based on data online. So crow of things
Crow thing.
is my idea for the
There's
example.
also Maybe I'll show everything else and I'll go back and maybe I'll show the text-to-speech tutorial really fast, if because we already have one. Okay, that's the easiest audio. So, it's on a breadboard. It kind of looks like a mess, but, if you were doing this, of course, you can pretty it up and make it all compact and solder it right on top. So I'm going to shut down this PiZero because this one's on a breadboard and I'm done with it. Thank you, PiZero, for your faithful service. And then I'm going to switch over to this PiZero. So, can we go to hover cam? Okay, so now that we're done with this PiZero, thanks. And we're going to, and I'll show really fast how to set up a USB to audio converter like this. These all use kind of the same generic chipset. So they're pretty easy to set up, and you probably have one kicking around. And if you do, they're again, really easy. So you can plug it direct, but I'm going to go through a hub because I need Ethernet to do these demos. So once you plug it in, you can just connect to the headphone jack. And these can also, they don't drive speakers. They usually just drive headphones, and you need a powered speaker. Okay, so this is booting. Okay, can we go back to the computer? Okay, so this is the tutorial we have. It's a generic tutorial. Okay, and since I rebooted, it reset the PWM outputs and stuff. So we still have that ALSA device. If you want to get rid of that, and I will just because we're no longer going to use the headphone, just comment out DT-param equals audio on, and that will remove the PWM output or HDMI output device. You can also do HDMI output. That's like automatic. You just select that in the Raspberry config. But I don't cover that because you just basically set to HDMI output. You have an HDMI display. It just works. But this way you don't have the ALSA device. So let me reboot. So we get rid of the BCM 2835. So give me a second. Are there any questions while I'm waiting for this to reboot?
Yeah, I have a few questions
Yeah.
that we can line up right away.
Sure.
All right. If you want to speed around these, would it be better then to add an audio hat to the PiZero?
Yeah, we have one, and I'll show off how to add one. It's just that if you have resistors and capacitors and an audio jack kicking around, or you have one of these generic USB audio devices, it's a no-brainer because it's so easy. It's just not going to be as the best quality will come from a USB to audio device, HDMI audio, or a DAC, basically. Either wired or in hat form.
Okay, is dev/mem a FIFO?
No, it's not like a pipe. You actually open it as a file, and you're seeking into the file and like writing the locations in memory. It's weird. I don't like it, but that's how you do it. I mean, that's how you access device registers. Usually it's hidden by kernel stuff.
Okay, what's the USB port in front of the scope?
You can plug in a USB key here and take screenshots and save data to it. However, this scope is 10 years old. It's a lovely scope, but I bought it like when I first started Adafruit, and it was like my first, I'm going to expense this purchase. And so the USB keys it needs have to be 2 gig or less, which are really hard to find. They have to be the old, some old style. I don't know why exactly, but it doesn't like modern USB keys, so I haven't been able to get it working.
What's cool is on our weekly show and tell, there's kids that are younger than 10 years old who have oscilloscopes.
Yeah.
That's neat. Okay.
This was a nice oscilloscope. Even at the time, it was like $2,000. And I was like, yeah, I'm going to get a color 4-channel scope, and it's like 100 megahertz. Sweet. This is I'm balling now. And now this is you can get these like on eBay
Yeah.
for like $50.
Okay. Could you pull power off the PiZero to drive a small speaker?
Yep, you can. Just make sure that the power going into the USB port is high enough. Make sure you have a good power supply, because if you have a bad power supply, you'll get voltage dips. And make sure you power the speaker from the 5-volt line, not the 3.3 volt line. The 3.3 volt line is hairy.
Could you do voice over Wi-Fi so someone could talk to their cat from work?
Yeah, absolutely.
Okay.
Yeah, that's a good idea. Scary.
Okay. Someone suggested that
DIY Alexa.
someone makes a Pi Chumby. That's a good idea.
You could make a Pi Chumby. You could, yeah, absolutely. You have the little TFT we showed yesterday. You have a little display of some sort, and have audio. Okay.
Okay, this question's for you, but I can answer it since I'm in charge of travel or not travel. Are we going to go to DEF CON this year? Probably not. We're sticking around New York. Have an Adafruit factory.
I haven't been to DEF CON in a real long time.
we both used to go to all the hacker events, and now we do video shows.
Do you think is it still at Alexis Park?
Yeah, I think so.
Oh, gee, I don't even. Well, we used to just drink a lot.
Yeah, I mean, Hope is.
I'm going to go to Hope.
Hope is here in New York City.
We're doing a small talk at
Yeah,
Hope.
we'll be doing something.
Yeah. Okay. You can listen to DEF CON radio in the meantime. Okay, where were we? Okay, so you're. Can we go to the computer? Computer. I'm going to wrap this up shortly. Okay, so if you're here, you want to just figure out what chipset you have. You can do D-Message, or you can do LS-USB, which will show you what's plugged in. In this case, I have a C-Media audio device. It's natively supported. It's OD8CVID, 00CPID. All you have to do is really update the ALSA config, because right now, if you do A-Play, I don't have that. We don't have that PWM, the PCM audio from the BCM 2835, but we do have card 1, which is the hardware device, card 1 device 0, which is the ALSA config device. If you want to make things a little bit easier for you, you can edit this and put this in, which will make the default be card 1, which is what we see here, right? This card 1. So that's kind of nice. And then I think you have to reboot, probably. You don't have to do this because we're on Wheezy. And then this.
Front, center. Front, center.
So in this case,
Front, center.
you still get that audio out of the speakers, and it's pretty easy. Like, you have to do almost nothing. And then also an ALSA mixer, you can increase the volume. There's a microphone input. I've never used it, but I'm sure it works. Like, there's no reason not to it, but I don't have any tutorials for it.
Front, center. Front, center.
Okay, great. So that's headphone audio. Super easy. Okay, so finally, you're like, I don't want any of these things. I want the fanciest audio possible. In that case, you can use a DAC, such as this fat DAC, and this is from PiZero. It's a lovely little DAC. Let's go to the Adafruit shop, because I know that we have photos of it. I can show what it looks like. And you don't have to use it on a hat. You can wire this up yourself. Just look at the schematic. I mean, these DACs are super simple. You basically give it 3.3 volt power, I2S like clock, channel select, data, no M clock, and there's like 4 signals. I can't remember the name of them. It's like LR clock, main chip clock, or signal clock, signal, whatever. And basically, it's like I2S is just standard protocol. It just automatically aligns itself correctly, and it's like all good, and it's like wonderful. This particular one has line out. There's also, Maxim has a chip like the Max 57382 or something, which is a speaker DAC. So you basically, it's a DAC with a speaker built in, but it's mono. So if you want stereo versus mono, you have a choice. So let's shut down. Oh, before we do this, actually, let's do the installation. It's pretty easy. you remove the old audio, which we've already done, and then you edit that A sound, and you can do that. So that's pretty easy. And then we already added basically this file. Go to boot config, and you tell it to load the Hi-Fi Berry DAC DT overlay. It's not a Hi-Fi Berry, it's a different DAC, but all DACs are going to use basically the same setup, so you can use one device tree overlay and it'll work with all of them. I can reboot. And then, actually, while I'm rebooting, okay, so can you go to the overhead? Okay, so I unplugged everything. I'm going to remove this USB audio, plug this in, and then we will plug this FAT, which is like a Pico hat. I don't know, small hat. So it's like a cute little thing, plugs on top. We'll still use this hub, give it power. And now we have a cute little on top thing. Okay, and then you want to go back to the computer? And we'll wrap this up. Oh, fun done. Okay. So we're logged in again. List, we have card 0 is sound RPi Hi-Fi Berry, basically just a DAC. That's the device from the device tree overlay. Let's edit a sound, because now it's card 0. I don't know why, like how it decides which one is card 1 and card 0, but USB is always card 1, DAC is card 0. So we'll just change also config so it knows. Do also mixer. Oh, this doesn't have any audio control. So if you try to do also mixer, it's going to fail. You don't have sound control over I2S. Some DACs do through I2C. You can control audio, but then you have to have like the interface for them. In this case, it doesn't. It's low cost. Basically, instead of controlling audio through software, you would just do it through hardware. You would change the volume of your device with a potentiometer or something. And now we can do that same speaker test.
Front, center, front, center, front, center, front, center,
Yes.
front, center, front, center.
Adjust the volume on my speakers have a little potentiometer basically in line.
That is my favorite Coldplay song.
Front, center, front.
Yesterday, you didn't even know who Coldplay was.
You've not seen my Chris Martin shrine.
So that's basically the demo. That's 3 different ways to add audio. So I think it's pretty good demo. I mean, you can also get HDMI audio. There's probably other ways you could hack audio out of this, but those are kind of like the 3 easiest ways. And they range from, the highest quality DAC to, plug and play USB speaker to grab a bunch of resistors and capacitors, wire it up, and like PWM, go to town. Depending on your needs, if you really need those PWM pins, you'll have to go with USB or DAC. If you don't care about losing PWM pins and you want it to be small and low cost, go with the analog output version. Many options.
Okay, you want to answer another question?
Yeah, we can do more questions.
All right. So we're going to answer your question.
Yes.
Can you stack the hats for more cards?
No, there's only one I2S output. So you can only have one DAC. However, you can have a DAC, the analog output, and a USB sound card. You can also probably have multiple USB sound cards. I don't have 2, so I can't plug in 2, but they'll just show up as multiple cards, which I don't see why you wouldn't be able to have multiple USB to audio adapters. So you could have actually like 3 out of the gate, USB, DAC, and audio. You can either have audio or HDMI. You can't have analog and HDMI at the same time because it uses the same subsystem. And you just select which card you want using ALSA. Okay, are there other questions or?
No, that's it.
Okay. Well,
That's
we could
everything.
wrap up.
40 minutes on the dot.
I think that's pretty good. I just want to show a tutorial. I'm not going to go over it, but it's a tutorial that we just recently added, and so I thought it would be good to show off because it's...
Oh, here's a question. Are
Yeah.
there any kernel configs that optimize for audio?
No, I mean, the audio stuff is all like, I mean, look, it's Linux, so, whatever. But these 3 systems are pretty well thought out. The audio that comes out from HDMI or from the PWM is a completely hardware-based subsystem, so like there's not a lot, there's like no work really involved. I think the I2S probably doesn't use that much bandwidth either. The USB probably does a little bit because it has to use the USB subsystem to take that audio and convert it to the right packet format and send it into the asynchronous USB system. But none of them are like super heavy duty. I think you're going to have more cycles burned on decoding the audio, which is just done in processor land.
Okay, next up, what are the pins for mic in?
The DAC apparently, I think the I2S has, this particular hat doesn't have audio input, but I believe there's an I2S input available, so if you wire up your own DAC. And then this has a microphone input, but I've never used it, but if you look for any Linux tutorial that has working microphone will probably work. And then you don't get a PWM audio input. There's no such thing.
Okay. Someone says, what do you think of a Raspberry Pi drawing robot? I think that's an excellent entry
That would totally be
for
awesome.
the
It would probably
Hackaday.io
win.
contest.
It would be-
Well, you
yeah.
should do it anyways because, ideas beget ideas.
You never know. Oh, so I wanted to show off.
In fact, the whole idea of Hackaday was to get stuff up there so other people came up with ideas. And I kind of looked at it like a skateboard culture where it's not competitive and you're not there to tear each other down. You're there to show off your tricks and see who can do the next best trick.
But it's also great to win free stuff.
And it's also great to win free stuff like the Tony Hawk. All right.
Can you just go to the computer? I'm going to show this
Yeah, I'll go to the computer.
Barella tutorial. So Mike Barella is one of my favorite Learn authors, and he's like, hey, I've been playing with text-to-speech, and I'm like, awesome. So this is a Raspberry Pi project. This is very handy for you. It's a great tutorial that you can use. And in this tutorial, he shows how to set up Festival and Flight, and how to script it through Python, which is a text-to-speech system. So you can have really good text-to-speech where you basically have a text file and it will read it out for you. I don't know if I can play a YouTube video from the YouTube video, but I'll try.
9:29 p.m. 9:29 p.m.
So he's demoing a button connected to a Raspberry Pi, and when he presses it, it speaks the time. So it's a talking clock. But these kinds of examples, maybe they'll inspire you to think of okay, well, you can have an interface that's completely voice-based because you can have the Pi speak to you what it's doing. So that's kind of neat.
All right. Well, that's that. I can't make any promises. However, I might fire up the Apple TV and put HDMI out to pump it to a live broadcast. We just updated our Adafruit Apple TV channel because we have an Apple TV channel. And we just pushed a bunch of podcast updates. So we're going to see how that goes.
Podcasts.
Well,
Podcatching.
Yeah, and we have this neat thing that takes the shows from our YouTube channel and should work. So I'm going to try that out. So we'll see. And then I also have to get HDMI out and get it to another computer. It's complicated, folks.
So that's what we're all about, being
Yeah.
complicated.
Yeah, and so, but those complications inspired lots of things. I get the 4-camera thing going on. That worked out
This is
tonight.
pretty cool.
Yeah, and we have, I think we're the first live broadcasters to broadcast PiZero stuff live off of a PiZero onto the internet.
And my favorite
So-
thing is this cool logo
Yes,
bug.
that stitches it all together.
Yeah, it's holding it. Look, it's like holding it together.
Yeah.
Got Scope Cam,
Okay.
got Pi Cam, got
Yeah.
Windows Cam.
Okay, well,
Betacam.
special thanks to the folks at Hackaday for partnering with us on this contest. Go to hackaday.io, enter your ideas. You will win a PiZero. There's a pretty good chance.
Yeah, there's a lot of great projects, but
Yeah.
there's always room for more. awesome projects. And don't forget, you can start working on your next 2016 Hackaday prize entry, and you can do that by entering this contest. It kind of keeping pace. If you enter this contest, you can win this one and that one. You can enter the prize in like both. You can build on your project. So if you're interested in winning like the $100,000 or whatever from the Hackaday prize, this is a really great way to get started. Build something useful and interesting with a PiZero. Document on hackaday.io, and you could be the winner of a Raspberry Pi Zero.
Okay, that's it. We'll see everybody during the week. Tomorrow is Ask an Engineer at 8 p.m. Eastern Time. Show until 7:30. Word of Electronics with Becky Stern at 2 p.m. And then some 3D shows. Thursday, we'll probably do another one of these, and/or this weekend. The Desk of Lady 8 is completely random. And we just do it when the desk is free.
Yeah.
Okay. All right. High resolution scope cam worked out tonight, too.
Think of a PiZero, any PiZero.
Okay.
All right. Thanks, everybody.
Okay, bye-bye.
And see you on the Hackaday.io.